So this week we realized that we didn't have a lot of R&D going. So the first thing that we did was we researched what a greenhouse does. After we did that, we designed some sketches that had to do with greenhouses. So we got it down to this particular design that had to be on someone's countertop. Once we designed the miniature greenhouse with a basic Illustrator document, we now need to make a template for that to laser cut. So laser cutting is probably going to happen on Saturday. We chose laser cutting for the project, one, because we have access to it, two, because wood is a nice aesthetic, I guess, for the project, and it's simple to build with. 3D printing is good, but it takes a really long time, and even though our build is only tabletop, it's still a pretty big build. Like, making a 3D printed version of this would take probably days to print. A laser cut version could take a minute.
So we just need to make the individual, the sides, the lid, and we need to get some hinges, and we're going to be laser cutting that. And then we're also currently working on 3D printing the case for the Arduino. Just, aesthetically it's better just so you don't have an exposed microcontroller, but it's also, because it's going to be soil and water, we want to make sure that it's not getting damaged or dirty.
We want to make sure that the Arduino is safe from the soil and water, so we also have to do that.
We did not design the case. It's from an open source website called Thingiverse, which is where people can, they make their models in whatever 3D modeling software they want, and then they upload the STL files to here, and it's just for anyone to use for anything. There's no, legal anything. It's open source. It's the website is made by the people that are, by MakerBot, which is one of the big 3D printing companies. The laser cutters and 3D printers really augment the process, giving us the ability to, not all of us are craftsmen. Not all of us are best with our hands. These machines help us by, giving us the tools to make, fine cut edges. Anyone can make a model on a computer, but, not everyone can make something that, just out of nothing, like with a saw. So this, this gives us the tools to, make what we need with, ease, I guess you could say.
So what we decided to do was create a website that branded our logo and our entire project very well. And then after that, we decided to go about creating profiles for people on the team so people have a greater understanding of what each student's background is. We also added in a page to look at the prototype design and everything we're working on, as well as a page to show all the content that we're creating graphically. There's a lot of collaboration going on. We're basically taking all the information from any group and putting it in just one area. So a lot of collaboration and a lot of communication between all the groups is necessary. Cool.
All right, so here's our Facebook website so far, or our Facebook page. We filled out all the about, short descriptions. We have the link right here to the full website.
I think a lot of people use social media now. I know my mom, that's what she does, is the reason she has a Facebook was for work. So she's very connected and has all these friends that are also on social media. So not everybody's gonna take their time out of their day to go to our website, but if they come across our Facebook page, then maybe they'll find it and look at it from there.
So this is the Arduino Super, and we plan on coating it with pH sensors and humidity, temperature and water sensors to tell us that we need more of, the plant needs to be watered, or the pH is too low, so you need to raise it, or if it's too hot in there for the plant to grow overall, that way you can grow the plant easily. So the Arduino is a processor, essentially. You're telling the computer by pins that we see here, send signals through to the breadboard, and then the breadboard will tell things like this LCD screen here to say lines like, hey, the pH is too low, or you need to add water to this certain plant, And it basically is all run through the computer, and once it compiles in the computer, you can detach it and have a battery attached to it, and the code will still run. So we're going to be using a pH sensor that will stick into the soil, and it'll tell us, it'll constantly read the pH level, and then we will set a timer on that. So every minute it will update the pH level and tell you if it's wrong. We'll be using a humidity and temperature sensor, both for the outside of the plant and the inside of the plant, so that you can make sure that it's being watered properly and it's not too hot or it's not too cold in the greenhouse.
Our role is to do research on the plants, find the soil pH and acidity, and like what environment and humidity and temperature pretty much certain plants grow in. And pretty much what we found is that certain plants will grow in the same environment. Say you got basil, thyme, and rosemary, they all grow in the same thing. So we're going to have a coding setting for that and give it to the coders on the data for that, and then other plants will have different coatings and different settings.
Yeah, we're really trying to target a general range for which certain plants, the environment that they grow in, which makes it easier for our coding team to develop a certain parametric for each setting.
Pretty much what we are finding is that certain herbs will grow in the same environment, and that other species will grow in separate environments, and pretty much we want to be able to have our coders have a diverse range of data that people can set for different plants, so they'll know how to grow certain species more efficiently than others.
Yeah, we're really laying the groundwork for this entire project because it really revolves around the plants themselves and what environment we can supply for them and whether or not they're going to survive. So all of the teams need to work together to, build this project, and it starts with us to really do the research and relay that and get everyone on the same page so that we can build a good environment for these plants to grow in. So